Okay guys, in this video we are looking at continuity of a function. The first one is that if function f is continuous at point c, a point where x equal to z, if and only if the limit of fx as x approach to c is equal to f of c. That's the first one. That's continuity at point x equal to c. If function f, next one is the function f is continuous on an open interval from a to b, if and only if every point in, if only if for all values c in this interval, the limit of fx as x approach to c equal to f of c. Meaning, if you want to have f continuous on open interval from a to b, every point on this interval must be continuous or satisfy this condition for all value of c in this open interval. And next one is a function f is continuous on a closed interval from a to b if and only if, number one, the function f is continuous on an open interval, which is this one, this interval, except point A and B. Okay, and number two, take a look at the endpoint of endpoint, which is endpoint on the left side of this function. Okay, so you have to look at the limit at the endpoint on the left side, the limit on the right side at the endpoint on the left side. So we're gonna have the limit of f of x such that x approaches to a plus equal to f of a. If we have this limit, that means that we have continuity on the right side of a. And the third one, take a look at the endpoint b. Okay, endpoint at b, we're gonna have, if you have the limit of f of x such that x approach to b minus, which is the limit on the left side of b, equal to f of b, then you're gonna have continuity on the left side of b. Okay, let's go to this problem. Let's start to do this problem. We're trying to show that if you have f of x equal square root of 9 minus x squared, show that f is continuous on this closed interval from -3 to 3. So the first thing that I want to do is to show that we are going to show that function f is continuous on an open interval from -3 to 3. Okay, how to show that? The way to show is that you got to let c to be in this open interval and then try to claim that the limit of f of x as x approach to c equal f of c. Okay, so now we have c in this open interval. So that means that c is going to be greater than -3, less than 3. Okay, and we want to have this term, or we want to show that when x is c, which is in this interval, we can have f of c. Okay, so the next thing I'm going to do is to add both inequality, add this inequality by 3. That means that we're gonna have c greater than 0, and then we're gonna have c plus 3, right, and less than 6. Okay, and subtract by c all of these sides of this inequality. So we're gonna have 6 less than c minus 3 less than 0. Okay, less than 0. So that's what we have. And then we multiply this term. So what do we have here? So we gotta have, so it's like I multiply c minus 3 on this side of this inequality. But c minus 3 is less than 0. So we're gonna have 0 times c minus 3 greater than c minus 3 times c plus 3 greater than 6 times c minus 3. Alright? And then we're gonna have 0 greater than c squared minus 9 greater than what? Okay, c minus 3 is greater than minus 6, right? So we're gonna have 6 minus 6 right here. And 6 minus 6 is 36. So we're gonna have 0 greater than c squared minus 9 greater than minus 36. Okay? Then we're gonna have 9 minus c squared greater than 0 less than 36. So that means that we have 9 minus c squared greater than 0. That means that we can plug in c in this right here. Okay? Because when c is in this interval, we can have 9 minus c squared greater than 0. Once the term inside square root is greater than 0, we can have square root of 9 minus c squared greater than 0. Okay. Now, since square root of 9 minus c squared is greater than 0, okay, that means that f is defined at c. Okay, that means that f is defined as c when c is in this interval from minus 3 to 3. Hence, what do we have? Hence, we're gonna have f of c equal to square root of 9 minus c squared. Okay, great. Now, what next? So what if we consider the limit of f of x as x approach to c, so we're gonna have the limit as x approach to c, okay, square root of 9 minus x squared. And we know that this function f is defined at c. So we can substitute c into this x, right? So we can have the square root of the limit as x approach to c of 9 minus x squared. And it turns out to be square root of 9 minus c squared, which is f of c. So we have shown that the limit of f of x at x approach to c equal f of c. Therefore, our function f is continuous on this open interval minus 3 to 3. Okay, great. So now our function is continuous on minus 3 to 3 on an open interval. Now, what about at the endpoint minus 3 and 3? So take a look at the endpoint. I gotta write at point x equal 3 at this point. Okay, the endpoint on the left side. So we gotta have the limit as x approach to minus 3 on the right side, f of x, which is the limit at x approach to 3 on the right side, right? Square root of 9 minus x squared. When x approach to 3 plus, that means that x approach to 3 and x is greater than 3. greater than minus 3. Okay, so this must be minus 3. And then what do we have? When x is greater than minus 3, that means that 9 minus x squared is greater than 0. So we can have this term approach to 9 minus 3 square equal to 9 minus 9, which is square root of 0, which is 0. Okay, and what is f of minus 3, which is square root of 9 minus 3 square, which is square root of 9 minus 9, which is square root of 0, which is 0. Okay, so that means that what do we have? We're gonna have the limit of f of x as x approach to minus 3 plus equal to f of minus 3. Okay, so that means that we have continuity. We have continuity on the right side of minus 3. Okay, we have continuity on the right side of minus 3. Now, what about the continuity on the left side of 3? The endpoint on the right side of this function. So we're going to have, at this point, x equal to 3. What do we have? We're going to have the limit of f of x such that x approach to 3 on the left side. So we're going to have the limit at x approach to 3 on the left side of square root of 9 minus x squared. So what do we have? We're going to have x less than 3, right? Okay, so this means that x approach to 3, but x is less than 3. So we're going to have the square root of 9 minus 3 squared. Okay, that means that this function approach to 0. Okay, and what is f of 3? F of 3 is square root of 9 minus 3 squared, which is square root of 9 minus 9, which is square root of 0, which is 0. Okay, so they are equal. That means that the limit of f of x as x approach to 3 on the left side equal to f of 3. That means that we have continuity on the right side of 3. Okay, continuity on the right side of 3. Okay, that's what we have right here. Okay, so therefore our function fx equal to square root of 9 minus x squared is continuous on where? Okay, we already have continuity on an open interval from minus 3 to 3. Okay, and we have continuity on the right side of minus 3, which is the endpoint of the closed interval, endpoint on the left side. And we already have the continuity on the right side of 3, which is the endpoint on the right side. Therefore, this function is continuous on a closed interval minus 3 to 3. Okay, that's it, right? Okay, so we have shown that our function f is continuous on the closed interval. Okay, and that's it for this video.